Okay, applying trigonometric functions to find unknown sides and angles, which sounds really impressive until you realise what are trigonometric functions. They're just sine, cos, tan. Well, for now anyway. Beautiful. First thing to note, this is only true. So it's if and only if you have a right angle triangle to begin with. If you don't have a right angle triangle to begin with, you're just not touching this sort of stuff, at least until you're a little bit more advanced, which we will do, but not yet. Cool, okay, so if you remember Sokotoa, brilliant. If you remember some other thing, fine. I don't care if you have to commune with the old gods in order to get this into your head. However you manage to remember it, it's totally fine, as long as you can spit out that afterwards. Fantastic. Incidentally, this is not sin, it's sine. This is cosine. Having said that, I'll call this sine, I'll call that cos. And tan is short for tangent, so I'll call these sine, cos, and tan, but it should be sine, cosine, tangent if you're using the full words. Beautiful. Okay, so we've got some right angle. We've got some right angle triangle. Fantastic. Typically for angles, we use Greek letters. So there's a whole bunch of Greek letters. You can literally just go Greek alphabet into Google and bring up a whole bunch of them. The only ones that we're going to use today, unless I change my mind halfway through, are going to be alpha, which kind of looks like a little fish, beta, which looks like a B, a capital B with an extended left side, and wherever I put him, theta, which looks like an O with a line horizontally across it. Beautiful. Also, FYI, it's theta, not theta. From Australia, theta? No, theta. Beautiful, okay. So, if I'm looking at the angle alpha, I can say, okay, this triangle has a side that is opposite alpha, an angle that is adjacent alpha, and an angle that is and a side that is the hypotenuse. The hypotenuse does not change, it's always the longest side. Similar to with a squared plus b squared equals c squared, c is always the longest side. For trig, h is always the longest side. Brilliant. If we look at things from beta's perspective though, or beta, usually beta, the opposite side is unsurprisingly on the opposite side, the adjacent is adjacent just means next to, and the hypotenuse is still the hypotenuse because the hypotenuse is always the same. Fantastic. Okay. Sokotoa, if you remember it, sine equals the opposite over the hypotenuse, hence SOH. Ka, cos of theta, cos of theta equals the adjacent over the hypotenuse, and tangent of the angle equals opposite over adjacent. Beautiful. Hopefully that's very familiar, but it's maybe slipped your mind in the last couple of days. Let's do one of these there, boys. Okay. First things first, generally a good idea. You can do this in your head once you're all across it, but if you're a little bit hazy, might be a good idea. Label your sides. So this is my angle of interest. It's usually easiest to start with the opposite, because it's the one opposite. Cool. The longest side is the hypotenuse, which leaves this one to be the adjacent. Fantastic. Okay. Next step, which ones do I actually have some information on? I've got nothing on A. I do have information on H. I don't have information per se on O, but it is the thing that I'm after, so I count that as information. So I've got O and H in play. Hopefully you know this off by heart, but O and H, that's sine. So we're going to be using sine for this particular question. So we write out our equation. Sine of theta, the angle, that's 30, equals O, which is x, over h, which is 10. Now, this guy, we're going to need a calculator for. So, sine 30. Now, there's a little bit of a problem with people using calculators sometimes, and this is always something that I suggest that you do every time that you start up your calculator, just in case it's been bumping around in your pencil case. Type in sine 30, close bracket, enter. You should get, depending on your settings, either 0.5 or a half. If you don't, you've switched the mode of your calculator. If you're using one of the green boys, you go up the top, there's a button for mode, and then along the top it'll say deg, rad, grad. You want deg, as in degrees. We'll be using radians later, but for now we will just want degrees. Fantastic. Always double check, sine 30, hit enter. Yep, I'm getting a half back, so I know that I'm in the right settings. Cool, alright, sine 30 is a half. So that's just type in calculator, enter, done. Cool, from here we've got a little bit of algebra. I want to get the x by itself. I want a fraction, so I'm going to have to multiply by that 10. All of this should be pretty old school at this point. A half times 10, that'd be 5. Good, we're done. That distance is 5. Beautiful. Okay, what about this thing? Okay, we've slanted it a little bit, so maybe it's a bit fiddly. If you're a little bit lost, just draw in the AO and H. Okay, here's my angle. This side is the furthest away, so that's the opposite. The longest side out of all of this is this top one, so that's H, and this guy's A, because it's adjacent. Fantastic. Cool, I've got information, nothing on O, I do have H, and I want A. So A and H, we go over to our memory, and that tells us that we should be using cos. Oh, lost the text. Okay, cos of angle 50 equals A, cos of theta equals A over H, so A is X, H 12, similar story, type them in, cos of 50 gives me some terrible number, 0.642787, blah 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 blah. Cool, most of the time you will get terrible ugly numbers. That's fine, we're only going to do approximations. Now, from here it was perfect, and this line we got a terrible decimal approximation. I will always endeavour to write wiggly equals. That means that it's approximately correct. Now, depending on the question, it might want 2 decimals, it might want 5 decimals, don't know. So, when you've got your calculator for the next, well, I'll show you what I mean. So, next stage. From here, I want x. I'm going to have to multiply by that 12 to get it off the bottom. Cool. Rather than saying 12 times 0.64278 or something and stopping, I'm going to use the calculator to say just multiply. It should automatically go ANS, meaning answer, multiplied by, and I want to multiply it by 12. This way I don't have to chop off any of the accuracy. Cool. So I get 7.71345513 something, and that will roughly equal x. Now if the answer specifically wants 2 decimals, great, I can report my answer as 7.71. If it says it wants 4 decimals, okay, 7.713 and then 5, because this would have rounded up. So that's the only thing you've got to be worried about is the rounding when you finally do answer. If you round anywhere earlier than the end, you are asking for trouble. Only round once at the very end. Otherwise you lose accuracy as you go, and that creates problems. Okie dokie, next guy. So, first things first, we're going to identify which one we want, without dropping textures ideally. Okay, well, there's this is the opposite. This would be the longest side, so that's hypotenuse, this is adjacent, fantastic. Okay, we've got information on A and H, so I'm going to need cos. Cos of angle equals A over H, so 10 over X. Okay, that's fine. Cos 30 gives me enter. And I'm going to do this as a decimal. If you've got this in exact, you'll get root 3 on 2, which is otherwise 866 point something, because I can't be bothered writing it all out. 10 on X. Okay, fine. So far so good. Now we want to get x by itself. Oh dear, x is on the bottom, so we're going to have to multiply. Oh, we're going to have to multiply by the bottom. Okay, multiply by x, multiply by x. Okay, we could have root 3 on 2 times x equals 10. If I have gone the exact route, in fact, I'll move this across a bit. Just to say we could have gotten root 3 on 2 equals 10 on x. Or if you're doing approximations, it would have been this. Notice that that's perfectly equal. So, always like things to be perfect. But, okay, so we'll move this across a bit. Root 3 on 2 times x equals 10. Or, we could have 0.866 times x roughly equals 10. Cool. If we're on the right side, we just need to divide by this to get x by itself, so divide by a terrible number. Again, you can use the calculator's functionality to just go what do we got? 10. So we type in 10 and then divide by. And then if you notice in the bottom right, there's in grey, A and S for answer. If it's in grey, hit your grey button up the top left, answer, enter. It'll say 10 divided by A and S. And then that'll give us an approximate, which is roughly 11.547 something, and then you round according to whichever decimal you want to round to. Beautiful. All right, what if we go this way? Well, here it's possibly a little less obvious, but we'll times by 2, because that's the bottom fraction that we need to get rid of. Okay, so I've got root 3x equals 20, and then from there, divide by root 3, divide by root 3. So we get x equals 20 divided by root 3. Now, if you type that into a calculator and ask it to approximate, you'll get the exact same result. If you want to be really fancy, you can say 20 root 3 on 3 by rationalising. I'm not particularly worried about that for methods. However, if you're planning on doing spec, you should definitely be doing that by habits. Cool, so that's that. And we've wandered a little bit into the next question, but that's okay. I'll just chop him off like so. Okay. Cool, next guy. All right, first things first, label if you're ever lost. So that's opposite, that's adjacent, that's hypotenuse. Cool, we've got O and A involved, so we're using tan this time. So tan of angle 40 equals O, 6 over A, x. Okie dokie. I'll use purple this time since I've already used red. Cool, I've got I need to sub that in. That will give me a crap number, 0.839 something equals 6 on x. Now if you're wondering, oh hang on, can't I get that in exact numbers? As far as we're concerned, no. Can you actually technically get that in perfect numbers? Yes you can, but it's going to be a lot of pain and you won't want to do it. If you're doing spec, you'd be able to do that with a lot of work actually, but that's okay. So we're not really worried about that. Just if you can do it exact, great. If not, don't worry about it. It's just a good habit to get into because shortly we're going to want to do pretty much everything exactly. Cool, we've got this, okay. Oh, I wrote that in the wrong colour. Good job. Let's go again. Because that should have been in red because that was my working colour. 0.839. Roughly equals 6 on x. Cool, we get purple. Okay, we want to times everything by the bottom of the fraction. Cool, so we've got 0.839 ... x roughly equals 6. And then divide by the ugly. Divide by the ugly to get x approximately equals 6 divided by answer 7.15, etc. Beautiful. Okay, that's all well and good. Next guy, all right, we've got a similar story, almost exactly the same. Well, it is the same at the start. Cool, first thing, label everything. Okay, that's O, that's H. A, not involved, don't have to worry about him. So I've got sine, brilliant. Okay, sine of, this time I've got theta equals O on H. All right, well, I've got this side I can simplify, in this case, to a half. Well, how do I do this? So what we want to do here is what's called an inverse trig function, or just an inverse function in general. In the calculator, it'll look like sine to the power of -1, and then it'll open up a bracket for you. We're going to put the half in there, and that will solve us for theta. So the way we do that, if you look at where sine is, just above it in grey is sine to the -1. So second sine gives us sine to the -1. We want half, enter, spits out 30 for us. It's 30, beautiful. And it's a nice number, so we're super happy. Cool, in a second we're not going to be happy. Next guy, okay, what have we got? We've got O and A, okay, so we're looking at tan theta equals O over H. Can't really simplify that any further, so we're stuck with tan inverse of 4/3 gives me theta. So these things are just switching places. That's all that the inverse does, it just reverses the function. So the inverse of times by 2 would be divide by 2. The inverse of tan is the inverse of tan, and we make 1. Inverse of tan, 4 on 3. bang, 50, which way have we got this? That way. Now this one gives us a decimal approximation, so it's rough, 53.13, garbage, garbage, garbage. Again, you cut it off wherever the question actually asks you to cut it off. So that's that. Most of this is pretty just formulaic and just done. Okay, onto things that can get a little bit more fiddly. We still have right angle triangle there, but I want this distance, but all I've got is one side. Well, that's not very helpful. Conveniently, however, I have some other information. Now, this might happen in application where you're measuring some distances on the ground, but this ground isn't flat, it might be hilly or whatever, and this is a bird's eye view. So this line you can measure perfectly fine because it's nice flat ground. Here it might go down a mountain or whatever. So you start to try and measure that directly. But you might have figured out, hang on, from this point on it's nice and flat, and that's 8, and I know the angle from here to there is 20. Can I do some thinking to figure this stuff out? Alright, well, let's consider what I'm going to call the outer triangle. So the outside here, well, that triangle is 6 on here, x plus 8 on that side, and 20 here. Alright, well, I don't really know what this x plus 8 side is, but I can still write that algebraically. So I've got O and A, so I'm still dealing with tan. So I've got tan of angle equals O, 6, over A, x plus 8. Okie dokie. Well, I want to solve for that x, so I better start moving him around. So I've got times x plus 8 times x plus 8. Also, I should have put in tan 20, so let's do that quickly. Tan 20 is 0.36 garbage, garbage, garbage. So I've got, if I can get my fingers through everything, 0.36397 garbage, garbage, garbage times x plus 8 equals 6. Fantastic. All right, well, timesing this by the x, well, that's going to give me the same thing as it said, but plus 8 times this thing, okay? So times that last answer by 8 to keep accuracy, 2.91176 garbage, garbage, garbage. Oh, this should have been rough because we had an approximation. Roughly equals 6. Great, well, I want to get x by itself, so I should get rid of this guy. 0.3637 whatever, garbage, garbage, x roughly equals 6 minus that, 3.088, garbage, 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 yeah. Beautiful, okay, now I want to divide by this old number. Oh, but I got rid of it. Conveniently, on these, you can scroll back up. So if you scroll back up, find that number, right, what we can do, actually, sorry, before we even do that, we want to do divide, because this is the number we want to divide. So let me write that. Oh, good job. Stuffed up my colouring again. Let's do that again. Sorry, I should have written that as my process. And then 0.3639 garbage, garbage. Roughly equals 6 minus this was whatever it was, 3.088 garbage, garbage. Brilliant, we want to divide by this thing, okie dokie. Divide by terrible number. Divide by terrible number. Well, this divide by that will just leave me with the x. I want to do this in the calculator, okay. I've already got this as my last line, so I'll hit divide because I just want to divide by this other thing. So it should come up with answer divide, scroll up to where this was, hit enter, and then it'll bring it down to the last line that you're working on. Enter again to actually make it calculate. Should get 4, 8, 4, 8, 6, garbage, garbage, garbage. And again, you can cut it off wherever. Cool. And that's that. So just by writing it as an expression, makes it a bit easier. There are other ways that you could do that. That's probably the easiest. Yeah, it's probably the easiest. Cool, alright, now I've got something like this here. This is even more annoying because now it's not even a right angle triangle, so it looks like we're defeated before we've even begun. However, we can be a little bit sneaky and go, well, what if I draw in my own triangle? just there, which is a right triangle. Okie dokie, and I say that this side and this side are parallel. Okay, can we do a bit of intelligent things? Well, if that's true, this must be 60 degrees. If these are parallel, this must be 90 and 90, so they have to add a 90, this must be 60. Therefore, this must be 30 as well. Similar story. Okay, great. Well, what if I put in another triangle over here, which is also a right angle triangle? Alright, well, I don't know what these are, so that's no good to me. But if I knew this side and used this side, I could get this angle. And then if I had this angle, I know this one, so I'd be able to figure out this one because the three of them have to add up to 90. Okay, so I want this side. Well, I can't get it from here, but this side is the same as this side. And I've got an angle and a side, so I can figure out this last side. So, let us figure things out. We'll call that alpha. I'll call this y. Actually, let's just call it x, sorry. Call this x, but then this x is the same as this x, so I don't have to worry about that. Beautiful. Okay. I've got the adjacent and the hypotenuse. That's cos. So cos of 60 equals ax over h 10. Fantastic. Cos 60 is half. So I've got a half equals x on 10. Multiply by 10. By 10. Half times 10 gives me a 5. 5 equals x. Great. So I've got my x. Alright, well, I know that this is 8 and this is now a 5, so I've got two sides, I want the angle. Okay, this is the adjacent, this is the hypotenuse. Again, that's cos. So I've got cos of unknown angle this time equals a, which is x, over h, which was 8, but we know x was 5, so this is 5 on 8. We need to rearrange for alpha, so cos inverse of 5 on 8. Equals alpha. Brilliant. Should I do that then? No, it's okay, look that. Beautiful. Cos inverse of 5 on 8. Close. Yes. Means that 51, etc. roughly equals alpha. Fantastic. Are we done? No. Originally we wanted theta. Where's my black marker is? Okay, so theta plus 30 plus alpha, so those are all together, altogether those equal 90. Okie dokie. Well, we still don't know what theta is. We do know what alpha is, so we can add those together. Let's go. Ooh, let's do purple, even better. Change this to purple, just so we can see what's going on. Cool, okay. So theta plus 81, etc. Will roughly equal 90. Okay. A little bit of algebra. We want theta, so we get rid of these guys. Minus 81.317. Therefore, theta is roughly equal to what? 8.682, 2-ish, so 1 something. Beautiful. And again, chuck it off wherever you need to, and that's that. Yep, beautiful. Now, we'll do 3D trig as well a little bit later, but for now we just need to get this sort of stuff down pat. This stuff you should be able to do in your sleep. This stuff you should be able to do barely awake. Just takes a little bit of fiddling around to either figure out what your expression is or to draw in extra triangles so that you can actually work with it. We'll also later on figure out how to do this without drawing extra triangles, but for now we're going to draw them. Excuse me, we have to draw them in. Beautiful, that's good. So that's 4A and 4B. Beautiful. Best of luck. Email if you get stuck. Bye.